My report is all about design speed, current speed limits, speed implications, speed restriction signs, highway capacity, classifications of highway, and accident information. Design speed. The design speed is the speed selected to be used in the design calculations in determining the geometric dimensions of the highway. The selected design speed should be consistent with the functional classifications of the highway, its surrounding land use, topography, and the driver's anticipated operating speed. A design speed of 110 km per hour should be used for freeways, expressways, and other rural highways, while urban arterials should design speed of between 30 to 70 km per hour. The lower range of design speed should be used for residential street, collectors, and downtown crowded areas, while speed in the higher range are applied to suburban arterials. The selected design speed should be an increment of 10 km per hour. Design speed is different than a specific design element because it establishes the range of design values for many of the other geometric elements of the highway. It is a fundamental choice for a designer. Next is the current speed limits. The current speed restrictions are set out in Chapter 4, Traffic Rules and Republic Act No. 4136, Land Transportation and Traffic Code. The provision of this act shall control, as far as they apply, the registration and operation of motor vehicles and the licensing of owners, dealers, conductors, and similar matters. The rules indicate that a motorist shall drive at a safe speed determined by the driver based on the road environment conditions such as 1. An open country roads with no blind corners, not closely bordered by habitation. The maximum speed for passenger cars and motorcycles is 80 km per hour, and for motor trucks and buses, 50 km per hour. On through streets or boulevard clear of traffic with no blind corners, when so designated, the maximum speed for passenger cars and motorcycles is 40 km per hour, and for motor trucks and buses, 30 km per hour. On city and municipal streets with light traffic, when not designated, through streets, the maximum speed for passenger cars, motorcycles, motor trucks, and buses is 30 km per hour. Next is the speed implications. Research shows that lower speed leads to fewer and less serious crashes. There are two reasons for this. At higher speeds, a rider or a driver has less time to react to a situation, and therefore there is a greater likelihood that an error will result in a crash. Most of the accidents happen because of this. When the driver or a rider drives very fast, there is instances that they cannot control it and it results for an accident. 2. The momentum and kinetic energy of a vehicle increase rapidly with speed. The sudden dissipation of this energy in a crash means that the injury to occupants is more severe. Therefore, a carefully planned speed limits can make a significant contribution to road safety. Next is the speed restriction signs. It is a regulatory sign that are designed to communicate a set legal maximum or minimum speed that vehicles must travel. Drivers must not exceed the limit that the design designates. Speed limit signs must be placed in prominent areas and repeated frequently enough for motorists to be aware of the speed zone they are in. A speed limit sign should be put on the left and right sides of the road at the commencement of a new speed zone. Then there should be 2 more pairs of repeater speed restriction sign inside the first kilometer. Following that, repeater signs should be spaced 1 kilometer apart. Repeater signs should also be placed before and after all major intersections to confirm the speed limit to all traffic turning into the road being considered. Next is the highway capacity. Highway capacity is the ability of the road to accommodate traffic volume. But there are situations that roadway conditions include geometric and non-geometric factors impact a road capacity. In others, they can affect a performance metric such as speed, but not the facility's capacity or maximum flow rate. Roadway factors include the following: number of lanes, the type of facility and its development environment, lane widths, shoulder widths and lateral clearances, design speed, horizontal and vertical alignments, axle loads, availability of exclusive turn lanes or at intersections. The horizontal and vertical alignment of a highway is determined by the design speed as well as the terrain of the area on which it is built. And the harshness of the terrain in general decreases capacity and service flow rates. Next is the classification of highway. Certain characteristics distinguish multi-lane suburban and rural highways from expressways. Multi-lane highway design requirements are often lower than expressway design standards, and their access points and turning volumes approach zero as they approach zero. In many ways, a multi-lane highway is comparable to urban street, although it has more control over the number of entry points per kilometer and speed restrictions. Pedestrian activity and parking are low in contrast to metropolitan street. Design requirements are typically greater than those for urban roadways, and speed restrictions are frequently 10 to 20 km per hour higher. A multi-lane highway is a form of roadway that allows vehicles to pass slower moving vehicles without utilizing oncoming traffic lanes. They are typically placed in urban areas and frequently connect urban regions. They offer superior design qualities than two-lane highways, such as horizontal and vertical curvature. There are still more classifications of highways, such as rural local roads, freeways, expressways, etc. As for accident information, to evaluate suitable safety enhancements, the accident history of all-purpose projects should be reviewed and potentially hazardous features and places identified. An examination of incident by location, kind, severity, contributory factors, environmental variables, and periods may reveal potentially safety flaws.